Hello everyone, this is my math clock for Dr. Zai's math clock event. I had a lot of fun constructing this math clock. I tried to incorporate 2026 into each puzzle, and then as I was working, I decided to try to incorporate each digit 2026 exactly once in each puzzle. Um, so I just kind of want to go through each of the little math things that I made and go through why they all represent the numbers that I say they do. So starting with 1, we have 2 to the 0 to the 2 to the 6. Um, so 2 to the 6 is 64, but 0 to 64, or just 0 to any number, is just 0, and then 2 to the 0 is 1, which is why that long exponent chain is just equal to 1 in the end. So for 2, um, we have 2 choose 2 plus 6 choose 0. And so in terms of combinations, or just basically saying if you have two items, what is the amount of ways you can choose two of them, which is just 1. And if you have 6 items, how many ways can you choose 0 of them, which is just 1, which is you choose nothing. You just have 2 choose 2 plus 6 choose 0 is just 1 plus 1, which is equal to 2. For number 3, have limit as x approaches 0 of 6 plus 2x over 2, which is really just a fancy way of saying 6 divided by 2, because as x approaches 0, that 2x term also approaches 0 and then goes away, and you're just left with 6 divided by 2, which is 3. So for number 4, as Dr. Zai explained in the original video, this percentage sign is used to represent the remainder function. So if you divide 202 by 6, your remainder is equal to 4, and that's why that is equal to 4. For number 5, this Greek letter phi is supposed to represent the golden ratio, which is the ratio that the numbers in the Fibonacci sequence approach, among other things. But I was originally planning on representing it using a geometrical construction, but that involves square root of 5, which is left as an exercise for the viewer in terms of constructing it in PowerPoint. So once you have the golden ratio, though, which is just 1 plus square root of 5 all over 2, the rest of the equation basically just undoes it to get to 5, multiplying by 2, and then subtracting 1, and then finally squaring it at the end, squaring root 5 to get to 5. So 6 is just simple. It's 2 plus 0 minus 2 plus 6, which is just 0 plus 6 is 6. I wanted to have one simple one in there, and I think the alternating pluses and minuses look pretty nice. So there's that. For number 7, the natural log of 2026 is around 7.6, and then on the outside there is the floor function, which it just says to round it down to the nearest integer, rounding down 7.6-ish to 7. So that's why that floor of natural log of 2026 is equal to 7. For 8, the sum of the eigenvalues of this 2x2 matrix 2026. There are a couple of ways to calculate the eigenvalues. The eigenvalues are basically just any value such that you can multiply this matrix by a vector, which is your eigenvector, and have it be equal to your eigenvalue multiplied by the same vector. There are a couple of ways to calculate the eigenvalues of this matrix, but since this is a diagonal matrix, you can just take the values along the diagonal, which are just 2 and 6, and I'll leave the full calculation of the eigenvalues as an exercise for the viewer. But there, since you just have 2 and 6, 2 plus 6 is 8, so the sum of the eigenvalues is just 8. For 9, this is a definite integral from 0 to 6 over 2 of x squared with respect to x. 6 over 2 is just 3, and then if you evaluate that integral is just 1/3 times 3 cubed, which is 27 divided by 3, which is 9. So yeah, evaluating that integral leaves you with 9. For 10, the left exponent there is supposed to represent tetration or hyperexponentiation. Basically what it's saying is to raise 2 to the power of itself 2 times, so 2 to the 2 to the 2, which is 2 to the 4, which is 16, and then 16 minus 6 is just 10. For 11, I wanted to do at least one geometry construction, and so I made this triangle, which I believe should be to scale. That angle should actually be 60 degrees. And if you want to calculate the side length there, what you can do is know that the cosine of 60 degrees, in this case of just the angle, is equal to the ratio of the adjacent side to the hypotenuse. So in this case, cosine of 60 is 1/2, and so 1/2 is the ratio of x to 22, which means that x is 11. And then finally, I have x squared plus 0 equals 2 times 6x, which, if you simplify it, is just x squared equals 12x. I wanted this equation to be able to represent both 0 and 12, and so the solutions to this equation are x equals 0 and x equals 12. So I hope you enjoyed those explanations of the math clock. I hope you enjoyed just seeing the math clock itself and all of the different ways to represent each of the numbers. It was a lot of fun to make it, and I'm looking forward to seeing what everybody else is able to come up with over the course of this little math clock event. I'm super excited. So thank you all for watching, and goodbye.